Right now, somewhere on the internet, you're saying things you never said. You're appearing in places you've never been, and you're doing things you never did. The scary part? It looks completely real. Your face, your voice, your movements, perfectly copied by an AI that learned how to become you. This technology is called Deepfake, and this is happening right now. And the technology behind it is both fascinating and terrifying. So what exactly is a deepfake? The name comes from two words, deep learning, which is a type of artificial intelligence, and fake, which, well, you know what that means. Essentially, a deepfake is a video, audio recording, or image where someone's face, voice, or body has been digitally replaced with someone else's. But this isn't like the cheap face swaps you might have seen in comedy videos. Deepfakes are convincing, sometimes disturbingly so. The technology emerged around 2017, and it's gotten exponentially better since then. What once took Hollywood studios weeks and millions of dollars can now be done by someone with a decent computer and a few hours of time. But here's the question that matters. How does a machine learn to fake reality this well? To understand that, we need to understand how a computer actually sees your face. Think of your face like a house. When you look at a house, you see the whole thing at once. The roof, the walls, the windows, the door. But a computer doesn't see it that way. To a computer, an image is just a massive grid of tiny colored dots called pixels. Imagine trying to understand what a house looks like by examining thousands of individual bricks one at a time without ever stepping back to see the full picture. That's how a computer starts. But here's where artificial intelligence comes in. Through a process called deep learning, we can teach a computer to recognize patterns. We show it thousands of pictures of houses, and slowly it learns, when I see pixels arranged this way, that's a roof. When I see them arranged that way, that's a door. Eventually, the AI doesn't just see random dots anymore, it sees houses. And the same principle applies to human faces. Creating a deepfake starts with gathering data, lots of it. If you want to create a deepfake of a specific person, you need hundreds or even thousands of images and videos of their face from different angles and different lighting with different expressions. This is why celebrities and public figures are common deepfake targets. There's already tons of footage of them online. Once you have this data, you feed it into something called a neural network. Now, neural networks are modeled loosely after how the human brain works. Your brain has billions of neurons that connect and fire in patterns to help you recognize faces, understand language, and learn new skills. An artificial neural network has layers of mathematical nodes that do something similar but with numbers instead of neurons. The network analyzes your training data in stages. The first layer might learn to recognize simple things like edges and corners. The next layer learns to combine those into more complex features like eyes, noses, and mouths. Deeper layers learn even more abstract concepts like facial structure, expressions, and how shadows fall on a face. This is why it's called deep learning. The network has many layers, each learning progressively more sophisticated patterns. But here's where it gets interesting. We're not just teaching one neural network, we're actually training two networks that compete against each other. This technique is called a Generative Adversarial Network, or GAN for short. Imagine two artists in a room. The first artist, let's call them the generator, is a forger trying to create fake paintings. The second artist, the discriminator, is an art expert trying to spot the fakes. The generator creates a painting and shows it to the discriminator. The discriminator examines it and says, "Fake. I can tell because the brush strokes are wrong." The generator learns from this feedback and tries again. They show a new painting. The discriminator finds a different flaw. This back and forth continues thousands, sometimes millions of times. Eventually, something remarkable happens. The generator gets so good at creating fakes that the discriminator can't tell the difference anymore. When that happens, you've successfully trained a deepfake system. In practical terms, here's what's happening. The generator neural network learns to take a source video, let's say a video of you talking, and map someone else's face onto it. It learns how that target person's face moves, how their skin texture looks, how light reflects off their features, even subtle things like how their eyebrows shift when they smile. Meanwhile, the discriminator is constantly checking this output against real videos of the target person, finding any tiny inconsistency. The generator then adjusts to fix those inconsistencies. The result? A video where your facial movements control someone else's face with disturbing accuracy. When you smile, they smile. When you talk, their lips move in perfect sync. The deepfake has essentially learned to puppeteer their face using your movements as the controller. But creating a convincing deepfake requires more than just swapping faces. The AI has to nail countless subtle details. It needs to match the lighting between the source and target video. If you're filming yourself in bright daylight, but trying to fake someone in a dimly lit room, the deepfake will look wrong. The system has to adjust skin tone, shadow placement, and even the way light catches in the eyes. It also needs to handle occlusions. That's when something passes in front of the face, like a hand or a strand of hair. The AI must track these interruptions and blend them naturally. Then there's the issue of expression transfer. A smile isn't just about the mouth moving, it involves the cheeks, the eyes, even the forehead. The network learns these correlations from training data. And we haven't even talked about audio deepfakes yet. Voice cloning works on similar principles but focuses on acoustic patterns instead of visual ones. An AI analyzes someone's voice, learning their pitch, tone, rhythm, accent, and speaking patterns. With enough samples, sometimes just a few minutes of clear audio, it can generate new speech in that person's voice, saying words they never actually spoke. Here's a thought experiment. Imagine you receive a video call from your best friend. They look exactly like your friend, sound exactly like your friend, and they're asking you for help. Maybe they need money urgently, or they need you to share some private information. Everything seems legitimate. But what if that's not actually your friend? What if it's a deepfake generated in real time by someone who collected enough data about them from social media? This isn't science fiction. In 2019, criminals used AI-generated voice technology to impersonate a company executive and fraudulently transfer over $200,000. As the technology improves, these attacks are becoming more sophisticated. The line between real and fake is blurring faster than most people realize. This matters because deepfakes aren't just a technical curiosity, they're reshaping how we interact with reality itself. On one hand, the technology has legitimate uses. Film studios use it to de-age actors or complete scenes with performers who've passed away. Educators use it to make historical figures speak in documentaries. Some people use it to create personalized content or artistic projects. But on the other hand, deepfakes are weaponized for harassment, fraud, political manipulation, and spreading misinformation. False videos of politicians saying things they never said can influence elections. Deepfake pornography, where someone's face is placed onto explicit content without consent, has become a serious problem, particularly affecting women and public figures. The fundamental challenge is this. For all of human history, seeing was believing. A photograph or video was considered evidence of truth. Deepfakes are breaking that ancient contract. We're entering an era where you can't automatically trust your own eyes and ears anymore. But here's the counterintuitive part though. The same AI systems that create deepfakes are also being developed to detect them. It's an arms race. Researchers are training detection algorithms that look for the subtle artifacts deepfakes leave behind: unnatural blinking patterns, irregular pixel texture around the face, inconsistent lighting physics, or subtle audio-visual desynchronization. But here's the twist within the twist. Every time detection methods improve, deepfake creators use that same technology to train even better fakes that can fool the detectors. It's the same adversarial process we talked about earlier, the generator versus the discriminator, but now playing out at a societal scale. We're locked in an endless cycle where fakes get better, detection gets better, fakes adapt, and the cycle continues. Some experts believe we won't solve this through technology alone. The solution might require digital authentication systems, blockchain verification for media, or entirely new frameworks for how we establish trust online. So that's how deepfakes are made. Two artificial neural networks locked in competition, learning from millions of examples until one becomes a master of imitation. It's a technology built on the same machine learning principles that power your phone's face recognition, your streaming services recommendations, and your voice assistant. But unlike those conveniences, deepfakes force us to confront an uncomfortable question. What happens when artificial intelligence becomes better at imitating reality than we are at recognizing what's real? We've spent thousands of years learning to trust our senses. Now we're going to have to learn when not to. The technology isn't going away. It's going to get better, faster, and more accessible, which means the responsibility falls on us to think more critically, to verify before we believe, and to question what we see even when it looks absolutely real. Because in this new world, the most powerful tool isn't the AI that creates the fake, it's the human mind that learns to recognize it.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time. Moving forward, we need to be more vigilant with what we trust from the internet.
It's actually extremely easy to make one of these things. There were just some supposed, breakthroughs from academic researchers who work with this particular kind of machine learning in the past few weeks, which would drastically reduce the amount of video you need actually to create one of these. This is kind of fake news on steroids, potentially. We do not know of a case yet where someone has tried to use this to perpetrate a kind of fraud or an information warfare campaign, or for that matter, to really damage someone's reputation. But it's the danger that everyone is really afraid of.